All right, more distributive property. Here we go. Example 1, use the distributive property to multiply. We have the quantity 3x minus 2 times the quantity 3x plus 4. I lovingly refer to these things as bubbles. Do you see the bubble? It's like a bubble and another bubble. Okay. These bubbles have 2 terms in them, and they have a special name that's called binomial. Bi refers to, what does bi mean? 2. Yes. Binomial. Here there are 2 terms. We have a 3x and we have a negative 2. So this is what we would call a binomial times a binomial. And we can use the distributive property in much the same way. So what I'm going to do is I'm going to take 3x and we're going to distribute it to both terms in the other bubble. How come I don't have to distribute 3x to the negative 2? It's already there. So I like to think of them, they're already friends. They're in the same associative bubble. They're in the same group. And so we're introducing them to these other folks over here. Okay? All right, so they have to multiply everything in the other bubble. So 3x times 3x becomes what? 9x squared. X times x is x squared. And then we multiply 3x times positive 4. 3x times positive 4 is 12x. Very good. Now, we also have to distribute the negative 2 to everybody over here. So everybody's introduced to one another. Negative 2 times 3x. Negative 6x. And negative 2 times positive 4. Negative 8. That's the distribution part. And then the last step is to just combine like terms. Does 9x squared have any friends? No, it stays 9x squared. Positive 12x and negative 6x makes what? Guys, quiet please. And then negative 8 doesn't have any friends, so he stays. This is the product. When we multiply these binomials together, we get 6x squared plus 6x minus 8. So you can see we have rainbows on top and rainbow distribution arc marks on bottom as well. Okay. Okay. So same thing, binomial times binomial. I'm going to take the b and distribute it to both terms. So we're going to multiply. B times b is b squared. And b times negative 4. Diego is what?
Negative 4b.
Thank you. And then we are going to distribute the positive 6 to both terms. God bless you. So we're multiplying 6 times b, positive 6b. Always give yourself a sign there, positive 6b. And positive 6 times negative 4 is, bless you, negative 24. All right. And what's the last step? Oh, I wrote an x. That shouldn't be an x. What should it be? A b. Yeah. I'm sorry about that. 6 times b is 6b. Last step, combine like terms. Does b squared have any friends? No. I'm seeing some folks not writing down their notes. I will be grading your notes. You get a participation grade for taking notes. Negative 4b and positive 6b is? Positive 2b is good. And a negative 24. All right. What's different about letter C? It's just one bubble, one binomial, but it's being squared. What does the squared mean? Multiply it by itself. So repeat. Repeat the base 2 times. Ladies and gentlemen, you must write this out. 2x plus 3 times 2x plus 3. Write it out 2 times, and then we can do the same thing we've been doing with distribution. So we're going to distribute 2x times 2x and 2x times 3. What is 2x times 2x? 4x squared. X times x is x squared. Good. And 2x times positive 3. Positive 6x. What else do I need to distribute? The 3 gets distributed. So 3 times 2x, another positive 6x. And 3 times 3, positive 9. What's the last thing we need to do? Combine like terms, simplify, same thing. So 4x squared. What is a 6x and a 6x? 12x's. And the plus 9. If a binomial has 2 terms, what would this be called? A trinomial. Very good. Tri as in 3. Trinomial. So binomial times binomial, pretty easy, but they get a little harder. Not really harder. It's not harder. It's just more. So what would this be called? This is a binomial times, what's that? A trinomial. Binomial times trinomial. 2x minus 3 times the quantity, x squared minus 3x plus 5. Now, distribution works, but we would take the 2x and distribute it, Diego and Jordan. We would distribute the 2x to all 3 terms, and we would distribute the negative 3 to all 3 terms, and that's a lot, and a lot of students tend to get lost doing that. So I have another method for these larger quantities called the box method. So what I'm going to do is I'm going to take my trinomial and write it x squared minus 3x plus 5 along the top of a box. And I'm going to take my binomial and write it along the side of a box. So I have a 2x and I have a negative 3. And so I'm going to create a box. And multiplication is simply finding the area. And what we've done now is I have 2 terms here. So I'm going to divide this box into sections and 3 little sections here to create 6 spaces to fill by multiplying. So multiplying is just finding the area of a shape. And so we multiply and fill in each little space. So this space is the product of x squared times 2x. What's x squared times 2x? 2x to the third. Very good. X squared times x to the first is x cubed. Same base, add exponents. And then I'm going to fill in this box, which is the product of negative 3x times 2x. What's negative 3x times 2x? Negative 6. X to what power? X squared. Very good. X to the first times x to the first is x squared. I'm going to fill in this box, which is the product of 5 times 2x. What's 5 times 2x? 10x. Filling in down here, x squared times negative 3 is negative 3x squared. The next box, negative 3x times negative 3, 9x. And the last box, 5 times negative 3 is negative 15. We just did all the distributing, and now we just need to combine like terms. And what's nice is everything's arranged super cool. Does 2x cubed have any friends? No, it's just 2x cubed. Then I have a negative 3x squared and a negative 6x squared. What does that combine to be? Negative 9x's squared. Very good. And then I have a 9x and a 10x. And what does that make? 19x's. And then I have that negative 15, which doesn't have a like term, so he just gets added onto the end. And this is our final product. All right, I'm going to do it again here. This is a trinomial times a trinomial. And again, I just really like the box method because it keeps things nice and neat. So I'm going to write one of my trinomials along the top of a box and the other trinomial along the side. So I have a 2x squared. Make sure you include the negative sign. So it's a negative 3x and then a positive 4. And then just how many spaces are we going to have here to fill in? 9 spaces. So divide it up and fill in the little areas. All right, what is x squared times 2x squared? Two x to the fourth. X squared times x squared is x to the fourth. Adding those exponents up. 2x times 2x squared is what? 4x cubed. Then I have negative 3 times 2x squared is negative 6x squared. Down here is x squared times negative 3x. Negative 3x is cubed. X squared times x is x cubed. 2x times negative 3x. Negative 6x squared. Negative 3 times negative 3x is 9x, positive 9x. Then we have x squared times 4. 4x squared. 2x times 4 is 8x. And then negative 3 times 4 is negative 12. And then the very last thing is just combining all the like terms. 2x to the fourth doesn't have a like term. We have a negative 3x cubed and a positive 4x cubed, which is 1x cubed. We have 4x squared minus 6x squared and a minus 6x squared. What is that? Negative 8x squared. Yep, negative 8x squared. 8x plus 9x is 17x's. Yeah, 17x's. And then negative 12 doesn't have a like term, so just negative 12. And there is our final product. The box method works all the time. You can do it with the binomial times binomial as well. I love how it just keeps things nice and organized. But distribution is the same thing.